Hi everyone and welcome back to NTE. In today's video what we're doing is we're practicing some circle geometry, right, and we're using November 2019 question number 9, right. Okay, so your first step when it comes to Euclidean geometry is always to read this given statement over here, right. And as you are reading this given statement, what you're trying to do is to make sure that everything that's written at the top, right, is also shown on the diagram. If not, it is your responsibility to insert it. Okay. Right, it says that in the diagram below, O is the center of our circle, right? That's always good information to know where the center of the circle is, right? ST is a tangent to the circle at T, okay? Right, now you guys know that I always like to highlight my tangents, and I find that it's even useful to write the word tangent right next to it, just so you remember. Okay. When we read further on, they say that M and P are points on the circle. Okay, so that just means that M and P are on the circumference of the circle, right? Such that Tm, right, is equals to MP. Okay, so we have two equal chords. Let us just indicate that. Right, then they carry on to say that OT, OP, and TP are drawn. Okay, so OT, right, OT is a radius. OP is also a radius. Okay, and TP is this line in between. They're just telling us that that is drawn. Okay, so TP is a chord, right? OT is a radius and OP is a radius. Okay, right, then they just say that let angle O1, right, which is this angle here in the center, let that equal X. Okay, let's just highlight that angle. So now that we've read our given statement, we now need to just start thinking about what does all these relationships imply. Okay, so the easiest thing to do obviously is then to work with these radii. Okay, because now you know that OT, right, is equal to OP. Okay, and you now have a triangle, right, an isosceles triangle TPO. Okay, we can even highlight that in purple, but it's going to have a common side, right, with this other isosceles triangle MPT. Okay, and that is just an isosceles triangle based on the fact that we were told, right, it was given to us that this chord MP is equal to the chord MT, right? So we can even now carry on to say that because of that, angle P1 is going to be equals to angle T2, right? And from the other side, right, angle T3, right, is going to be equals to angle P2. Okay, let's go back to this tangent, right? The angle between the tangent and the chord in this diagram is T1. Okay, so that's T1, and notice which chord does it touch, right? It touches the chord MT, right? So you're going to go from the chord MT, right, and you're going to travel to the circumference, and when you do that, you see that it subtends the angle P1. Okay, so this angle P1 is equals to angle T1. Now it's always good to check, right, which other angle does the tangent form with a chord, right? So we've already seen that it forms an angle with the chord MT, right? But what about the chord PT, right? What about this angle, right? Does that chord subtend any angle at the circumference? Well, in this diagram, unfortunately not. But if we need, maybe we might construct our own chord, right? And then we know that this angle would have the relationship with this angle O1, right, where O1 will be twice this angle here, the circumference, right? But chances are we won't have to go to that length, because remember this is a final paper, so they usually don't put anything that requires any constructions in our final papers, right? So we're most probably not going to have to worry about that. Okay, so the only thing that we have to worry about is the fact that this T1 is equals to angle P1. Okay, just put back my ones there. Right, so I think that's about it that we can get from this diagram. Let's see what the question says. Very nicely, this question was just one simple question, right? They wanted us to prove, right, that angle STM is equal to 1/4 of x. Okay, right, so where is angle STM? Angle STM is actually angle T1. Okay, right, so we're going to say angle STM, right, is equals to angle T1. Okay, that can be our first statement. There's no reason for this, right? It's just from the diagram. Okay, so now basically we just now need to prove that angle T1, okay, is equals to 1/4 times x, right? So where does this x come from, right? So this x comes from angle O1. Okay, so we're going to have to work with angle O1 in some way. Okay, so now we have to find a way, okay, to take this x into this orange triangle, right? So if I continue highlighting this, okay, into that orange triangle MPT, right? Why do I want to take it into the orange triangle? Well, because inside of that orange triangle we have this angle P1, right, which is related to this angle T1, which we ultimately have to find because T1 is equals to angle STM. Okay, so circle geometry is all about just finding the connections between all of the angles. Okay, so the way that we're going to take this x into this orange triangle is by using the angle at the center, right, is equals to twice the angle at the circumference, right? But which angle at the center are we talking about? Okay, so we're going to be talking about this reflex angle, right? So angle O2, right? And remember that I always say to you guys that when you want to find the relationship of the angle at the center with the angle at the circumference, right? It's always nice to always look at the arc that subtends that angle, right? So you can see that when you're looking at the reflex angle, angle O2, that's subtended by the major arc PT, right? And the shape of the arc is what helps you to identify the angle, right? So notice that we have this shape going, right? So you'll see that that's the same shape that's at the center, right? Which means that the angle at the circumference is this angle over here, angle M. Okay, so now that we've identified that, right, we can now write our next statement, right? So our next statement is to say that angle O1 plus angle O2, right, must be equal to 360 degrees, right? And this, the reason for this is angles around a point. Okay, so then therefore from that we can say that angle O2 is equals to 360 degrees minus x. Okay, then our next statement is going to be that angle O2, right, that's the angle at the center, right, that is equals to 2 times the angle at the circumference, right, which in this case is angle PMT. Okay, so angle PMT. Okay, then we need to write our reason. Okay, the reason is angle at center is equals to 2 times angle at circumference. Okay, so then now we can then say that therefore angle PMT, okay, that's going to be equals to half of angle O2. Okay, so you can imagine taking this 360 degrees minus x and substituting it over here, then you'd need to divide it by 2. Okay, so angle PMT is equals to 180 degrees minus 1/2 x. Okay, right, so this is good because now we are in triangle PMT, right, which is this orange triangle that we're trying to get into, right? So now we can say, next statement, in triangle PMT, okay, we have that MP is equals to MT, right, and this was a given statement, okay, right, so then from that, therefore, angle T2 is equals to angle P1, right? Reason for this is angles opposite equals sides. Then you can even name them MP equal to MT. Okay. Then we have the next statement that we can say, right? Angle PMT, right? So this green angle, right? Plus twice angle P1, okay? Twice angle P1 because this comes from angle PMT, right, plus angle T2 plus angle P1, okay? Those are the interior angles of this orange triangle, right? But remember that angle T2 is equals to angle P1, so this is just angle PMT plus angle P1 plus angle P1, right? So we're going to have 2 angle P1s, which gives us that, right? And we're going to choose to work with angle P1 because angle P1 is related to angle T1, okay, which we are ultimately trying to calculate. This must equal 180 degrees, right? Reason is sum of angles of the triangle PMT. Okay, so from there we can then say that therefore twice angle P1 is equals to 180 degrees minus angle PMT. We just calculated angle PMT over there. That is 180 degrees minus 1/2 x. Okay, so we'll have that twice angle P1 is equals to this negative will multiply or distribute into the bracket. Okay, so that's going to cause us to have 180 degrees minus 180 degrees plus 1/2 x. So the 180 degrees will cancel each other out. Okay, so we can just go straight into writing 1/2 x. Okay, so then therefore angle P1 is equals to 1/2 x divided by 2. Okay, but that is the same as saying 1/2 x times 1/2. Okay, so then we have that angle P1 is equals to 1 times 1 is 1, 2 times 2 is 4, so 1/4 times x. Okay, which is good because that's exactly what they wanted us to prove. Okay, the next statement is angle P1, okay, You can even write here, because we are proving, you can even write here but. Okay, angle P1 is equals to angle T1. Okay, what's the reason for that? Well, it's by the tan chord theorem. Okay, and then we can then conclude that therefore angle STM is equals to angle P1. Okay, so then therefore angle STM is equals to 1/4 times x. And that's it. That's the end of our proof.